It's a real pleasure to be here. A little bit of background is that 10 years ago, I've been at the Water for Food conference, and I've been here many times over the years, so it's a real pleasure to be here today again. 10 years ago, I was coming as a Monsanto representative working on introducing the drought trait into the western United States. We did actually get that launched in 2013, and since then I've been working on projects in Africa, and my new title is Director of Collaborations for Developing Countries. So guess what? Today one of the key messages is going to be that to deal with the complexities and the challenges in water, collaborations are key. There isn't any one organization, one approach that's going to work. Water is an extremely challenging issue. And we're at Bayer very excited to be part of the conversation and work to help bring solutions to water and food security. I'm going to share with you our business perspective on that today to try to give you a sense of how we as a private sector think about how we can engage in this. And I look forward to feedback from all of you and insights about how is it that a private sector, a company like Bayer, can be more effective to help in this area to address some of the key issues that we face from a societal basis. As we think about it and set it up from a standpoint of overall megatrends and how we look at the marketplace, I think it's very important to first set that sort of high-level view of why this is important. We have a growing population. We expect to have an additional 2.2 billion people. There's going to be need for 50% more food and feed, so a growing population is a big driver in what's making things happen in the world. There's also pressure on the ecosystems. Climate change is reducing harvests by 17%, and we're actually seeing significant loss of arable land per capita of 20%. All of these things come together into creating societal needs. We need secure and sufficient supply of quality food, and we have to manage our natural resources in a sustainable way. At Bayer, we believe that science for a better life is part of the solution to that. We do believe innovation and technology is central to being able to address these megatrend challenges that we face. As we think about shaping agriculture to benefit farmers mostly, but also consumers and the planet, we really need to think about what are the key parts of our mission? What are we as a company able to do, and how do we participate in this? So we've broken it down into basically 3 pillars that we think that we have a role to play in. One is deliver world-class innovation. We have a huge amount of research, a lot of technology that can be brought to bear on these challenges of food security and water use. Digital transformation, we can be a pioneer in that, looking at how do you use big data, all of those opportunities of digital tools for smallholder farmers as well as large-scale farmers. And then the other thing is to set standards on sustainability. We really have to think about how do we do all of this and do it in a sustainable way that's going to have less impact on the environment and yet deliver the needs for the society. And all of this comes together in coming up with tailored solutions, bringing seeds and traits, crop protection, and digital ag together. And I think that when we talk about water in particular, we come up with a real need to have tailored solutions, because the water issues in Nebraska have a lot in common with other places in the world, but they're not the same as the water issues in Africa. Each location has its unique challenges, and we have to come up with tailored solutions that are going to work in those particular places. So a real focus on trying to come up with how are you going to create a tailored solution to all of that, bringing those elements together. So this is not intended as a trick question. What's the biggest biggest issue in agriculture today? Actually, it's the same today as it was 20 years ago, and it will be in the future. And I like this graphic because it shows that water is our #1 issue, and the crop per drop is really the measure that we have to talk about. We really have to focus on this is the main issue that agriculture faces. Everything else is secondary actually to water, because water is the #1 issue that we come across, and some data to actually support that. If we look at a 44-year history about corn production in the United States, the major losses, 67% of those losses across those years is because of drought. That doesn't mean that the other things aren't critical or important. It's just that when you look at the actual data of what actually happens, water is the main issue that farmers are dealing with and cause their losses. And so it needs to be brought into being part of everything that we do to think about how do we manage water judiciously and efficiently. 1/3 of the world deals with water scarcity issues. This map particularly highlights the issues in Africa. Clearly, the map is a general view. I mean, we have water issues in Nebraska as well, but generally speaking, water supply is not the same sort of issue here in Nebraska as it is in Africa. So again, across the whole world, we look at this and we see there's regional challenges that have to be addressed, and we have to think about those solutions as they fit into each particular geography. So achieving water and food security lies at the intersection of multiple technologies. So what I'm going to take you through is how we think about these three things coming together. Agronomic practices is what I'll focus on first. Then we'll go to biotechnology, and lastly, plant breeding, to give you a sense of how, from a private sector, we think that our part of innovation and what we can participate in this fits together in all of these areas. But agronomic practices is one of the most fundamental that we can work on. So there's things like conservation tillage, major change in the way of the water is used. If we think about this part of the world and the Dust Bowl in the 1930s versus how agriculture is done today, almost all of that is because of agronomic practices, reduced tillage, management of the water that's supplied in the soil. A lot of that comes from understanding your variability of the soils in the first place. So understanding your soils is really critical to being able to manage the water, and so the agronomic practice is part of that. The other thing that you can look at is planting rates. You can really change your dynamics of what you're actually able to do because of the planting rate. So we bring all of those things together as agronomic practices. We also do a lot of research collaboration. So at our Gothenburg Learning Center here in Nebraska, we work with the University of Nebraska in collaborative research on irrigation. And I'm not going to go into the details of that irrigation research. The point is that there's a lot of research that can be done and is being done collaborative with different organizations. And at Bayer, we are very excited about being able to have those sorts of facilities, those capabilities, and those relationships with the academics and the public sector to be able to come up with those sorts of research that is going to make a difference for farmers. We're also part of a collaboration called the Midwest Row Crop Collaborative. So this is a group of diverse companies involved in expanding the agriculture solutions to protect air and water quality and enhance soil health. So a big feature on this is about soil health. We really have to work on what is the management of the soil, because that is the fundamental piece of managing your water in those areas. And the collaborative is working on a few priority watersheds, trying to look at the agronomic practices that are in those watersheds and say, how do we reduce the runoff from there? How do we manage the water flow that's out of that so that it becomes sustainable and it reduces the hypoxia, for example, in the Gulf of Mexico. So again, collaborations is a major part of what we're trying to do from a standpoint of addressing water issues. Future goals of the Midwest Row Crops Consortium is to ensure 50% of the row crop areas of the Mississippi River Basin use soil health practices by 2025. They're also trying to reduce the nitrogen by 41% and phosphorus by 29% by 2035. And here specifically to the Ogallala aquifer is to 50% of all the irrigation that's to be used is to maximize the water conservation and reduce water quantity stress by 2025. So again, collaborations, organizations coming together, trying to find solutions and saying there isn't going to be one way to approach this. It's really about this holistic approach and understanding, and it's an example of a coalition that can come together with the private sector and the public sector to address big challenges that we face in the Midwest. The next part of agronomic practices really comes to precision. I think that if we're talking about the next generation of where things are going to go from a standpoint of agronomic practices, the real focus is on data and how do you become more precise? How do you make better decisions? So we have a company within the company called the Climate Corp. And the belief within the Climate Corps is that the next breakthrough in agriculture will be utilizing data and analytics to optimize decision making. And the mission there is to help all the world's farmers sustainably increase productivity with digital tools. So it's a big aspirational aspect, but there's a lot of work going into generating data, getting the data to come together to create that. So collecting and leveraging data to create value, bringing in data, machine learning and recommendation, and then the deep science that goes with that data, all coming together to create value for digital agriculture. Specifically to water, the Climate Corps has goals on irrigation, which align with the Irrigation Innovation Consortium here on their focus areas. So on sustainable engagement, the area that we focus on is water and energy efficiency, but also on the technology side, the remote sensing and big data applications, irrigation technology, and systems integration. So we have a lot in common with the Irrigation Innovation Consortium and work at the Climate Corps on our work with water. Past engagement with the Irrigation Consortium, we had 25 growers enrolled, 27 experiment setups, 31 pivots across this area, and it was set up so that half of it was done with the grower rate, a quarter was done with the Climate Corps rate for subfield level, and then the UNL rate for the field level. This is a way to generate data to really understand what practices actually work and generate deep insight and knowledge based on data to actually drive decisions that are going to be based on evidence. Out of that, what we're able to do at the Climate Corps is to actually utilizing satellite imagery, weather data, plant stage, solar radiation, relative humidity, and evapotranspiration to create this sort of visualization of the amount of water that's actually being used in the field. That can talk about when the farmer's able to start to see what the actual water use is, they can make better decisions about replacement irrigation needs, the timing of irrigation, how much you actually need to use. So this is one of the fundamental challenges that irrigation faces is we don't know exactly how much we need to put on, so we tend to put on more than what we know simply because we don't have a gauge that shows whether the tank is empty or not, and so we fill it up more than we may need to. So that sort of data can come in and really help drive decisions. It's a precision agriculture application that's able to actually increase the efficiency of water use. So that's the work that's going on. So our current engagement with the IIC participants is continue the joint research and comparative studies during the 2019 season with additional center pivots and equipment sharing. The Climate Corps is presently considering joining the ICC as an industry partner to be part of the research steering committee. And our internal discussions within the larger Bayer organization are being conducted. So at this point, there's no announcement to be made or anything. I just would say that we recognize this work that's being done by the ICC. We're trying to evaluate what our role is in that. And that's where we look for feedback from all of you is how does the private sector engage in this and do a meaningful collaborative work that is actually going to lead to better outcomes for all of us. So moving on from agronomic practices into biotechnology is one of the ways to address this water and food security issues. I'm going to take you back to a picture that actually, in my mind, it's recent, but it's actually pretty old now. In 2005, we were introducing the rootworm control, the biotechnology trait for rootworm control. And this was a field in Illinois. And on the left hand, this is exactly the same variety, the two different sizes. It's just one has the soil insecticide control and the other one has the biotech trait for the insect control. And what it shows here is how important roots are to manage water. So when we think about how you're going to address water issues and be more efficient with water, you really have to get below the surface and understand what's going on with the roots. And I think that this was not so much, from a water standpoint, it was not so much a wake-up call about soil insecticides versus biotechnology, but it was more a wake-up call of, wow, there's a lot going on below the soil that we don't really know about, and a huge amount of effort that needs to be done to understand how we can get better root systems, how we protect those root systems, because it's a fundamental aspect of being able to manage your water use and get the best water use efficiency available. other challenges that we had was launching the Drought Guard trait. Whenever you're testing water and drought tolerance, your biggest challenge is actually environmental variation. You have such noise in the data because there is so much environmental variation going on, and it's a real challenge for all of us that are doing research to be able to do that. So we, certainly put all sorts of trials in places where it would have the least probability of having rain happen, but we started making jokes about our drought trait that it was the rainmaker gene, because almost every time we put a trial out, it would rain and it would wreck up your data. And so it's a real challenge to get that good data there. So we did create this rainout shelter, which can actually roll over the top of the crop there, and you can actually control the amount of water that is actually being applied in a very specific way, so that the weather, you're exposed to the weather, but you're protected from the rain. It's a big investment, but it's a recognition of the challenge that it is to do good data on that. And here's just some examples of Drought Guard hybrids that we're able to do with. You can do a 4-inch irrigation treatment and compare it to a 16-inch, and you can start to put together real graphs that show what's your response to the actual water that is there, and really start to get good data sets about what is the impact of the genetics that are behind all of this, to be able to separate that out and separate out the genetics from the environmental piece of that. So Drought Guard has been in the marketplace for since 2013. It has had good success with many commercial farmers, but again, it's one of those challenging traits where it's not always evident what value it has, because it is so difficult to measure. Farmers have that same challenge, and this is one of the things that, as a research organization working in water, we always need to be understanding of this complexity of the variation in the environment and how difficult it is to make good evidence-based decisions on that. The last part that I'm going to talk about is plant breeding, and I'm going to switch to talk a little bit about what I'm doing now is with the Water Efficient Maize for Africa project. We took this same drought gene to Africa, and we've made it available royalty-free in Africa, along with the BT trait. So it's a project that started over 10 years ago, so we're in year 12 of it now, moving forward, trying to get drought tolerance through technology into the marketplace in Africa, and using regular plant breeding along with biotechnology. So this project partnership, it involves, it's funded by the Bill and Melinda Gates Foundation and USAID, and the partners in it are CIMMYT. Now there's 7 National Agricultural Research Services, mostly in East Africa, but we just added Nigeria as well. And then it's managed by African Agricultural Technology Foundation. So we just had our annual meeting. There's probably around 80 people in the room from all these 7 different countries working on drought tolerance. And a big part of what we were doing was plant breeding to improve the drought tolerance of the native genetics there in Africa. But the objectives from our perspective at Bayer is what we're trying to do is help improve the fundamental infrastructure and policies in Africa to enable sustainable seed systems, and also to share our knowledge and leadership to help establish holistic systems-based water and food security in Africa. So really trying to take all of this technology that we have in the world and say, how do we get it into an African environment, test it in an African environment, and be able to get this technology to smallholder farmers to improve their livelihoods. So drought stress in Africa, I don't think is any surprise to anybody in the room, but it's just a reminder of how serious this can be and what sort of challenges the smallholder farmers face. And this magnitude of it, over 650 million people depend on maize in sub-Saharan Africa, and recurring droughts pose a continuous challenge to maize production. So of the areas in the world that have the highest incident of recurring drought, Africa is certainly at the top of the list, and it's a common issue, and it actually is one of the key drivers of why there's such low investment, actually, because they're so risk averse. Because the risk that they're going to lose their crop from drought is actually quite high, therefore it makes it more difficult to say, I want to make the investment to actually have a good crop. There's also lots of challenges from a standpoint of research. Just being able to do good research in Africa is a real challenge. There's a lack of mechanization for economic operations. Remote sites lack supervision, and I had to add this picture of the elephant tracks on the right-hand side because I've never done a trial before working in Africa where elephants were actually an issue. But we have to actually put up big fences and things around just to be able to manage those issues because you are in a very different environment. There's also challenges of seed movement across countries. So when you're talking about this, although we talk about Africa as one place, quite honestly, it's 54 countries with a lot of diversity even within those countries and lots of bureaucratic challenges sometimes of actually just trying to get seed movement from one country to the other. So we've learned a lot in that process and working with the Africans, and so this is another part that from a private sector business of where we're at that we really gain a lot from being in public-private partnerships where we have to learn how to get things done in a different environment, in a different way than what we would normally do it perhaps in our US circumstances. Just to give you some examples of what's been made progress from a breeding standpoint, working together with CIMMYT and the NARS on their breeding programs, we've got some drought-tolerant and susceptible hybrids where you can actually see the visual difference on the susceptible hybrids versus the drought-tolerant hybrids. So clearly progress is and can be made through plant breeding processes to actually create products that are going to work better in those environments for smallholder farmers. They also use marker-assisted recurrent selection, so trying to use some of the latest technologies, apply that to genetics to be able to do a quicker, faster, and better job of doing the research. And we've got some experiences there where that technology has also helped lead to drought tolerance in the base genetics. At the same time that we're improving this base genetics, we're integrating the drought trait and also the BT traits. And I didn't include all of that results there, but I can tell you that there are very marked improvements that you see, particularly with the fall armyworm that's come into Africa attacking the plants. And so this is where, when we think about the challenges of addressing drought tolerance and everything in Africa, we also have to think about the holistic approach, that it isn't just about drought. There's also insects, there's diseases, there's all of those things that have to come together. So it really creates this need for a very holistic, systems-based approach that is really being owned by the Africans and saying that this is in their circumstances what it is that they need to do to be able to address their challenges. So to wrap up, is sort of from a standpoint of our view on sustainability engagement and the broader impact, at Bayer, we're interested in engaging in all of this, working through collaborations, but we've broken it down to access programs. We're focused on empowering 100 million smallholder farmers by 2030, so we've set our aspirations very high. We know that we're not going to be able to do that on our own. We certainly need everybody in the room and everybody involved in agriculture to put in their contributions and work together to be able to address these huge challenges that we face. We also need to reduce our ecological footprint. So we're advancing a carbon neutral future for agriculture, understanding that climate change is a major driver of these issues. Climate change and water use are so inextricably linked that we certainly need to be thinking about how it is we address that. And then there's also a significant reduction of inputs, so more crop per drop, more productivity, more efficiency, so to speak, to drive that. And water smart agriculture initiatives are certainly a central part of what we need to do to be able to deliver on our objectives and our goals and what society and farmers actually in Africa and all around the world need. So I think that we all see that the challenges are huge. The complexity is great, but also the opportunities are big. And we need to figure out what is the way to turn all of this into a sustainable system. And as we think about sustainability, it's really about these three pillars. It's got to be environmentally sustainable or benign. It needs to be socially acceptable, but it also has to be economically viable. And bringing in that last piece of the economically viable and creating systems is one piece that I think that the private sector in particular can play a strong role in saying, when we evaluate projects and what we think going forward, we are constantly as an organization thinking about the economic viability, because that's how we get paid. So it's really important to be thinking about how all of these things fit together and how we work together. So with that, I say thank you very much for your time. I look forward to participating in the conversation here for the next 2 days, and really look forward to how, as Bayer, we can contribute to these efforts and help make a difference to make water and food security a reality. So thank you.